Alright, with all of those instructed theorem and for nodal and mesh analysis, let's really practice them in several examples. So 4 examples. Example 1, find the V0 by conducting nodal and mesh analysis in both circuit A and B. Obviously, we have 2 circuits, and for each one of them, we're going to apply nodal ones and then mesh ones as exercise. And in exam, we just need to apply either one. Okay. Here, also be careful. I'm asking for the equations and the equations only. So let's see how to do this, because in the exams, we also have problems asking for equations only without algebra calculation. Okay. Let's take a look at the circuit A. Let's try nodal first. So we are basically seeing multiple nodes. And if you recall the previous slide, we don't want to select the corner nodes here and the corner nodes here. And also we don't want to select the bottom ground node whose voltage is 0. Therefore, only one node left right in the middle here for us to write KCL. And then also another thing to be careful is the voltage we are looking for, V0, is the voltage cross 6 kilo ohm from this node with respect to the ground here. Okay. With those being said, let's take a look at the solution here. So we basically seeing, first of all, selecting the middle node here, and we need to define a voltage at this node as V. Since we're only choosing one node, so we don't have to have a subscript to differentiate from any others. Okay, so V at this node, and to write a KCL, we identify there are 3 branches currents. So what we want to do is assuming current direction. My assumption of current directions are labeled as these, and feel free to assume any otherwise because it not matter. However, when we write equations, we have to follow the assumed current directions. Okay, so at this node, what we have is all of the currents leaving the node here, as I assumed. So sum of them all up should end up with 0. So how to write the current here flows through 4K from right towards left. So from the circuit, we can tell we have this voltage V minus the corner node voltage divided by 4 kilo ohm as Ohm's law equals to the current flows through 4 kilo ohm and towards left. However, if you recall the previous slide again, we don't want to use the corner node. So instead of using corner node, we directly use the V and the ground 0 volts. So we have a here V minus pretty much 0 divided by from V all the way down to ground, we go through 4 kilo ohm and 2 kilo ohm. That's why in the denominator we have 2K plus 4K. So this is actually the current here towards left. Next, let's take care of the current down here going through 2 kilo ohm and 3 volts. Okay. Here, the voltage cross 2K itself is V minus this node voltage. However, what is this node voltage? By reading the circuit, you should be noticed at this node, the voltage is nothing but 3 volts with respect to the ground. So we have V minus 3 divided by 2K equals to the current flow through here. And of course, this is also the current through 3 volts voltage source. However, by the voltage source voltage value 3 volts, we can never tell the current through. So we have to use Ohm's law on one resistor, 2 kilo ohm, to come up with the current through this branch. Okay, be careful with this tip. Last current is here, flows through 6 volt. So how to find the current here? The same issue we encountered in this branch. The 6 volts voltage source cannot tell us about the current, so we have to use the Ohm's law on 6 kilo ohm resistor to express the current through this branch. And of course, 6 volts source current is same as the 6 kilo ohm current. So how to write this current here? So voltage at this node minus the ground 0 divided by 6 kilo. So what is the voltage here? You have voltage at this node as V. And then by increasing 6 volts, you reach this node voltage. Because in the middle, you have a 6 volts here, voltage source. So from here, jump over it to reach this node, your voltage potential increased by 6 volt. It is increasing rather than decreasing because of the polarity of the voltage source here. Okay? So again, V jump over this voltage source, reach the voltage potential of this node we are looking for. Therefore, V plus 6 equals to voltage at this corner node. This voltage minus 0, this voltage minus 0 divided by 6K equals to the current through this branch here. This branch here, okay, which is also the current here. Okay, sum these three currents up, you end up with 0. Of course, here be careful, and in this equation, 3 divisions individually is current term. However, inside of it is in terms of voltage, node voltage. Okay, this is how we write the nodal equation. And this is obviously one equation, one unknown, from which we can find out the V, node voltage V. And what is V naught value? V naught is, as we analyzed, the voltage here with respect to the ground. Therefore, the V plus 6 equals to V naught. So correct answer for V naught for this particular circuit is 6.6 volt. This is applied in nodal. Now let's try mesh to solve the same circuit, should ending up with the same voltage value. So first, let's choose 2 mesh here and here, and again, clockwise rotation direction, clockwise current flow direction as well. So in this mesh 1, we call it mesh 1, and current of the mesh is called I1. Current of this mesh 2 is called I2. So let's get it started. Okay. So to this circuit, pretty much mesh 1 here and the mesh 2 here. To each one of them, we are starting right the KVL. So first of all, we are coming across 2K and the 4K here. Both are having the same current, which is I1. Introducing a voltage positive here, negative here, and positive here, and a negative here. Following this, so you have 2K plus 4K times I1. The total voltage across 2K and 4K. Plus the voltage across 2K here. Obviously, as we said before, you have 2 currents going through 2K. One is downward I1, another is upward I2. So following your rotation direction, you are writing the voltage across it equals to 2K times I1 minus I2, rather than I2 minus I1. The last term is the voltage source voltage, which couldn't be easier as 3 volts. So plus 3 equals to 0. Okay, this is the first mesh equation. In terms of I1 and I2, 2 mesh currents. To mesh 2 here, follow same idea. So in mesh 2, we first of all have a voltage cross 2K. Previously, we are following this voltage polarity in the first equation, right? So 2K times I1 minus I2, introducing a voltage cross 2K following such voltage polarity. If so, and then since our rotation direction is this way, we are coming across negative first, followed by positive. Therefore, we should have a negative 2K times parenthesis I1 minus I2. Okay. Of course, same as mine here, because I don't have negative in front. However, in the parentheses, I'm using I2 minus I1, same thing. And the next, you come across the 6 volts here, which is negative first, followed by positive next. So negative 6. And then you have voltage cross 6 kilo ohm. Due to I2, it introducing a voltage having such voltage polarity. So it's 6K times I2. Positive. The last one is the 3 volt voltage source. Again, due to the rotation direction, we are coming across negative first, followed by positive. So it's a negative 3 volts. So these are 2 mesh equations in 2 meshes. If you count, you have I1 and I2, 2 unknowns, and the 2 equations. So all set. You got I1 and I2 values. After these 2 values, we should focus on what it is asked for, which is V0. V0 is the voltage here. Okay. So how to find V0? V0 obviously by Ohm's law equals to the 6K times the current through it, which is I2. So equals to 6.6 volts. Same result as previous nodal analysis. Hopefully this is clear. And if so, let's talk about the circuit B. So by nodal, we are selecting nodes. Okay. We don't like the corner node, we don't like this corner node, and we don't like the bottom super node ground either. So we are choosing node 1, node 2, and node 3 with assumed voltage V1, V2, and V3. This is the first step. Right? Second step, assuming the currents with directions. So if you assume current here as this way, and this way, and here this way, and this way, again, whatever you want. Okay, the key is your equation following the assumed current. And then we start to write the current. First of all, this current. If you look at the original circuit, it equals to the V1 minus the node here, voltage, divided by the total resistance, which is 2K series with 3K in the original circuit. So what is the voltage node here? Right above the 10 volt source, what is the voltage at this node? Same thing as here, right? So it equals to 10 volt. So V1 minus 10 divided by 2K plus 3K is the current here. Next, the current down here is very straightforward. So just equals to V1 minus V2 divided by the 4K it going through. And then the current here is equals to V1 minus the voltage here divided by the 4 kilo ohm in the middle. The voltage here is what? This is the most tricky part of this problem. The correct answer is the voltage here is equals to V3 minus 12. How could that be? And the reason is very simple. We have a 12 volt voltage source here between this node and V3. So based on the 12 volts polarity, we can tell these volts go lower this 12 volts, or in other words, this voltage point increased by 12. is equals to V3. Therefore, this is what? Less than V3 by 12, right? So the voltage here is V3 minus 12. And you're using V1 minus V3 minus 12, like this. Divide by 4K in the middle equals to the current here. So let's see at node 2 here. Again, 3 current. I am assuming 1 going in, 2 leaving out. So going in current here is already taken care by previous equation. So just copy. And then this current here is equals to V2 minus V3 divided by the resistance in the middle, which is 6 kilo ohm, and then plus this current. And then let's see what is this current. This current is also very tricky, same as this part. So we have a voltage source here. Again, polarity very, very important. With this particular polarity, 8 volts. And then you have a 3 kilo ohm here. So what you want is use V2 minus the voltage here between 3 kilo ohm and 8 volt. V2 minus this volt divided by 3K equals to the current flow from V2 downwards to the ground, right? So what is the voltage here between 8 volt and 3 kilo ohm? It's actually just equals to 8, right? So V2 minus 8 divided by 3 kilo ohm in the middle equals to the current down here. At V3, let's see. We have this current has been taken care by the first equation, and plus this current here, which has been taken care by this equation here, equals to the current leaving it here. So which is equals to basically V3 here minus the ground 0 divided by the resistance in the between, which is 6K ohm. These are 3 nodal equations, which eventually in terms of node voltages. Some algebra down here, which might not required in exam, so be careful. And then you got the node voltage V1 through V3. And now is the time again to focus on what is really asked for. So if you go to the circuit back here, you see V0 you're looking for is nothing but the node 3 voltage, V3, from this node to the ground. So V3 is equals to V0, equals to eventually 8.96 volts. This is using the nodal to conduct the circuit analysis. Now let's see the mesh to solve the same circuit. 3 mesh, obviously. I call this as 1, here 2, here and 3. So respectively we have I1, I2 and I3 flowing through as mesh currents. KVL in mesh 1. So we are having first of all 10 volts as this polarity. So you're coming across negative first, followed by positive. So this is negative 10. And next you have 2 kilo ohm and 3 kilo ohm. And they are following such voltage polarity due to the I1. So you have 2K plus 3K times I1. And then you have 4K here has 2 currents flow through. One is downwards I1 and there is upward I2. Therefore 4K times I1 minus I2 with this polarity. And then you have 3K down here. 3K again, you have 2 currents flowing through, downwards I1 and upward I3. So 3K times I1 minus I3. The last one is the 8 volt voltage source with this polarity. So positive first, negative follow. So positive 8 eventually equals to 0. Okay. This is KVL in loop 1. In loop 2, let's see. So first of all, you have voltage across this 4K here. If you're following the previous equation, you know the voltage polarity is like this. And due to the rotation direction in mesh 2, you are coming across negative first, positive next. So you should have negative 4K times I1 minus I2, which is equal to nothing but 4K times I2 minus I1. And then plus the next 4K up here. With I2, it is introducing a voltage polarity like this, positive here, negative here. So 4K times I2 as the voltage cross 4K here. And then you need a voltage cross 12 volts voltage source. This is couldn't easier. Negative first, positive next. So negative 12. So next you have 6 kilo ohm, which has again two current. One is from right towards left I2, another is from left to right I3. So if you follow I2, you should have positive 6K times I2 minus I3. And then sum them up equals to 0. Loop 3 down here. So if you follow the polarity we have established from previous equation, you should see negative 8 minus the 3K times I1 minus I3, well, which is equivalent to positive 3K times I3 minus I1, minus 6 kilo times I2 minus I3, which is equivalent to 6K times I3 minus I2. And then last, you have another 6K. Due to I3, you have voltage polarity like this. So plus 6K times I3 equals to 0. 3 equations and 3 unknowns on 1 through I3. And V naught is equals to I3 times 6 kilo. End up with same voltage value, 8.96. In the exam, again, if only equation required, you should stop by here. So these are 1, 2, 3 mesh equations. Same thing for nodal. If no algebra is required, you should stop by here. Only 3 equations in terms of bunch of node voltages. So this is the example 1, circuit A and B.